Today's video is on the problem related to Laurent series, and this topic is from complex power series. And in today's video, I am going to find the Laurent series of the function f of z is equal to z by z plus 1 into z plus 2 about the point z is equal to minus 2. So it is very clear that the function f of z from the question is z by this is z plus 1 into z plus 2. Clear? Now I am going to resolve into partial fractions. See, this can be written as f of z is equal to z times of 1 by this is z plus 1 into z plus 2. Now I'm going to write this as f of z is equal to z times of this is a by z plus 1 plus b by this is z plus 2. Clear? And now I need the values of a as well as b. So I'm writing 1 by z plus 1 into z plus 2 is equal to this is a by z plus 1 plus b by this is z plus 2. Now, if I take LCM, see here, this is 1 by z plus 1 into z plus 2 is equal to, here, this is z plus 1 into z plus 2. It is a times of z plus 2 plus b times of this is z plus 1. Clear? Now, if I cancel the denominator on both sides, then the equation will be 1 is equal to a times of z plus 2 plus b times of this is z plus 1. So, in order to get the values of a as well as b, so here it is plus 2. Now, if I put z is equal to minus 2, see what happens here. So, this will be 1 is equal to minus 2 plus 2, this is 0, plus b times of this is minus 2 plus 1, and therefore 1 is equal to b times of minus 1, and therefore b is equal to minus 1. So I got the value of b as minus 1. So here it is plus 1. So if I put z is equal to minus 1, so b will be 0 and I'll be getting the value of a. So 1 is equal to a times of, in place of z I am writing minus 1 plus 2 plus 0. So 1 is equal to a into 1. So I got the value of a as 1. So after substituting a value here, a is equal to 1 and b is equal to minus 1. So if I put here in this equation, as a is equal to 1 and b is equal to minus 1. So consider this as equation 1. Therefore, our f of z value is equal to z times of, see here, this is z times of, in place of a as 1 by z plus 1, and in place of b as minus 1 by this is z plus 2. Clear? Therefore, we got the value of a as 1 and b as minus 1. And now see here, the point here is z is equal to minus 2. See, remember this one. So, we have the region z is equal to, see here, z is equal to minus 2. Now, if I bring this z inside, multiply with z, then f of z is equal to, this is z by z plus 1 minus this is z by z plus 2. See here, f of z can be written as, see, this can be written as I need z plus 2. So wherever I find z, I am writing z plus 2 and balancing with minus 2. See, here also there is z. So I am keeping plus 2, and in order to balance minus 2, and there is already plus 1. See, here also there is z. So I am keeping plus 2, z plus 2. Since the region here is, so if I consider this as z plus 2 is equal to some say w. See, I need the region z plus 2. Therefore, I am adding 2 and subtracting 2. And here already there is z plus 2. Keep it as it is. And now see, the next step will be, see the continuation part of this. So f of z is equal to, so f of z is equal to, this is z plus 2 minus 2 here, this is z plus 2 minus 1 minus, so this is z plus 2. So I am considering this as single term by z plus 2, and minus of minus, this is plus 2 by this value is z plus 2. Clear? This value is z plus 2. Now see, this can be f of z is equal to So if I take minus common, this will be 2 minus z plus 2, and here if I take minus common, this will be 1 minus of z plus 2. Clear? And if I cancel this minus, and here if I cancel this for one time, so one time this will be 1 plus 2 times of this is z plus 2. And see, f of z is equal to, I am bringing these two to the front side. See here, this is minus 1 plus 2 by this is z plus 2 plus this value is 2 minus this is z plus 2 as it is. And if I take this denominator to the numerator, this will be 1 minus this is z plus 2 inverse. And see, f of z is equal to, this is minus 1 plus 2 by this is z plus 2 plus this is 2 minus this value is z plus 2, and this is of the form 1 minus x inverse. So as you know that 1 minus x inverse, here minus, here also minus, so everything will be plus 1 plus x square and so on. I'm using that expansion. So if I consider this as x, this will be 1 plus z plus 2 plus z plus 2 square plus z plus 2 whole cube plus and so on. Clear? Now this will be f of z. So f of z is equal to, this is minus 1 plus 2 by this is z plus 2. If I multiply each and every term with 2, see 2 into 1 is 2, 2 plus 2 times of z plus 2, clear? 2 into z plus 2, and again 2 into z plus 2 square plus this is 2 into z plus 2 whole cube. This is z plus 2 whole cube plus and so on. And here if I multiply with this will be minus z plus 2, and if I still multiply, this will be minus z plus 2 square. So if I multiply, this will be minus z plus 2 whole cube and so on. Clear? And this value will be f of z is equal to, see here, f of z is equal to, this is minus 1 plus 2 by z plus 2, and here it is 2, and if you observe this one, this is plus 2z plus 2, and here it is minus 1 into z plus 2. So 2 minus 1 is 1, and therefore our next step will be 2 minus 1 is 1. So this will be z plus 2, and here if you observe this one, z plus 2 whole square. So this is plus 2 times of z plus 2 whole square, and this is minus 1 times of z plus 2 whole square. So 2 minus 1 is 1, and therefore this will be plus z plus 2 whole square. And the next thing is z 2 times of z plus 2 cube, and this is minus 1 times of z plus 2 cube, and this will be 1 time 2 minus 1 is z plus 2 whole cube plus and so on. So this is 2 minus 1. Here the value here is f of z is equal to 2 minus 1 is 1 plus 2 by this is z plus 2 plus this is z plus 2 plus this value is z plus 2 whole square plus z plus 2 whole cube plus and so on. So this is nothing but the Laurent series for the region z is equal to minus 2. So this is how we have to solve. This is also so simple if you follow these steps. First of all, the thing here is, so here the function f of z is given as z by z plus 1 into z plus 2. So I have taken z aside and split into, resolved into partial fractions. So after getting a as 1 and b as minus 1, again I have substituted a as 1 and b as minus 1. Here we have taken the region z is equal to minus 2. So we can write as z plus 2. So wherever I find z, I wrote z plus 2 and balanced with minus 2 here. So here also plus 2 minus 2. And after balancing, see here, this will be z plus 2. So after taking minus common from the numerator as well as denominator, and this is after cancellation, this value is 1 and this is 2 by z plus 2. See here, I wrote minus 1 here, 2 by z plus 2 here, and this value, the numerator is as it is, and I have taken the denominator to the numerator, so it will become inverse. So this is of the form 1 minus x inverse, and I have expanded as 1 plus x square plus x cube and so on. So remaining are as it is. So this is minus 1 plus 2 by z plus 2, and this is 2. See here, so if I multiply each and every term with 2, so these are the terms, and again minus z plus 2, if I multiply each and every term with minus of z plus 2, so this will be minus. See here, this is minus z plus 2, minus z plus 2 square, minus z plus 2 whole cube. And after simplifying, I got this expansion. And this is how we have to solve. Thank you so much for watching and staying till the end. If you really understand, please practice and definitely you can score more.